Hello everyone, my name is Paul Harris and I'm here with Ben Hale to give you an overview of version 2 of the Cloud Foundry Java client. I'm going to start with a brief explanation of how the CF Java client works, then I'll hand over to Ben, who'll give us a demo of how to get started pretty much from scratch with some code. At the moment, there are a couple of ways to interact with Cloud Foundry programmatically. The first of these is the Cloud Foundry API. The CF API is a REST API. You call a given URI, generally with a JSON payload, and you get a response message, again, generally with a JSON payload, that provides the result of your request. As you might expect from a modern API, the CF API is stateless and asynchronous. And the CF API is low level. It's about interacting with Cloud Foundry in fine detail, which allows you to do pretty much everything that CF allows, which is great, but it also leaves you to do quite a bit of work. The other way to interact programmatically through the CF CLI. This is a command line interface, so suitable for humans, but it is also amenable to scripting. It is again stateless, but this time it's synchronous. If you're doing something that takes a while to complete, the CLI will make you wait until it has the data you requested or the task you initiated is finished. Probably its most attractive characteristic is that it's high level. In the case of the sample command shown here, an apparently simple CF push, there are around a dozen individual tasks and tests being chained together. For example, you need to check whether the app already exists, or if we're trying to create a new app, you need to map requested routes if necessary, check for domains, and so on. So, those are the two existing ways of interacting with Cloud Foundry programmatically, neither of which is ideal for a Java application, which is why we have the CF Java client. So what is the CF Java client? Well, simply it's the Java API for Cloud Foundry. It works at two levels. We have a client level, which is equivalent to the CF API. So it replicates the Cloud Foundry API, but takes care of the complications of accessing a REST API from Java. Our goal at the client level is to reproduce all of the CF API, the only changes being to make it more Java-like. For example, there are various statuses that CF API returns that we convert into enums to help you out. By having the client layer mirror the CF API so closely, we ensure that if you can achieve something through their API, you should be able to do it through ours. The second level of the CF Java client is the operations layer. This is where we chain together various client-level calls to achieve more complicated goals, such as pushing applications or creating services. This layer replicates the functionality of the CLI, but again, it's in a Java style. So almost all of the CLI calls exist in the operations layer, or they will do soon, but we've tweaked various request options to make sense in Java. Similarly, the return objects sometimes add or remove individual fields according to what makes sense for Java. For example, we very often return object IDs that on the command line wouldn't necessarily be useful. Just as with the client layer, our goal is that if you can do something using the CLI, you should be able to do it using the operations layer. Like the underlying REST API, the CF Java client is stateless and asynchronous. We decided that the best way to achieve this was by using a reactive programming model. So why did we use reactive? Reactive programming is fundamentally asynchronous and non-blocking. This means that all the hoops we're used to jumping through in imperative programming to deal with these things are no longer a problem. Though, as Ben will show you in a moment, reactive does have one or two of its own hoops to deal with, but still much simpler than trying to do things imperatively. With the reactive approach, we're able to broadly define event-driven systems, letting the underlying reactive implementation deal with issues such as orchestration. We concentrate on what we want to have happen and let somebody else worry about the details of when it should happen, making sure everything's in the correct order and so on. Using a reactive approach allows for stable, scalable access to external systems. Under normal loads, we're able to use resources more efficiently, and in the face of exceptional loads, we can handle them gracefully, if not always perfectly, rather than just dying. That's one of the major benefits of being reactive, that we can cope with loads and we will continue to cope with loads rather than just failing spectacularly. We're not programming reactively for performance, but we have found that it can lead to performance gains. Letting someone else worry about the orchestration lets us, and in turn you, concentrate on the most efficient ways to gather the data that you require. The foundation we've used for our reactive approach is Project Reactor. Project Reactor is a Spring project that will form a significant part of Spring 5. You don't have to use Reactor to use the CF Java client. In fact, one of the benefits of a reactive API like ours is that you can access it quite simply from imperative code if you have to. But as Ben will now show you, using CF Java client in a reactive style, based on something like Project Reactor, allows you to produce elegant, efficient code. Okay, Ben, over to you.
We're going to start today by attempting to replicate part of the CF CLI application. What we're going to do is we're going to attempt to replicate the CF apps command. And the CF apps command lists all of the applications in a given organization and space, along with some additional information about them. So as we can see here, when I ran CF apps, we see that there is a Java main application that is started with one instance and a set of memory and the URL that you use to access it. To replicate this same behavior inside of the CF Java client, we need a special object, and that special object is called a Cloud Foundry Operations. And the Cloud Foundry Operations we're going to get from this Spring application context above. So now we know we want to use a Cloud Foundry Operations. How exactly do we create one of these? If we wanted to create one of those, we would use something called the default Cloud Foundry Operations, and we'd use its builder. Its builder tells us exactly what arguments we need to configure it. And so if we took a look, one of the things we'll need is something called a Cloud Foundry client that Paul referenced earlier. We see that we have one injected into this particular bean definition, so we'll just go ahead and create that. We also want to set exactly what organization and space we would like to connect to. And then the final touch is that we use the Builder API to build and return one of these. You'll see that the organization and space that we're going to use are configured using environment variables around this application. When we take a look here at the things that we inject into the Cloud Foundry Operations, we see that it builds on top of that low-level Cloud Foundry client API. So let's go ahead and create one of those as well. In this case, we want one specific implementation of the Cloud Foundry client, and it's the one backed by Reactor. So much like the Cloud Foundry Operations, this has a Builder API. This Builder API, once again, tells us the kinds of things that we want to configure. And there are two different things that we want to configure. First is called a connection context, which we'll take a look in a second, and the other is a token provider. Once again, we'll go ahead and build and return that type. So the first of those two objects, the connection context, allows us to configure how exactly we make a connection to a Cloud Foundry server. In this case, we'll use a default implementation of that. And it asks for a number of different things, allowing you to configure, for example, the keep alive timeouts or the port that you're going to connect to. But in our particular case, we want to connect to a specific API host. In this case, it is injected into us. The other dependency that we want to create is something called a token provider. And the token provider turns out to be really, really important because this is the way that we configure all of our authentication and authorization against the Cloud Foundry server. In this particular case, and the one you'll probably want to start using, we're going to use something called a password grant token provider. And if you're familiar with how OAuth works, password grant is going to be very common to you. This is the most common case where you provide a username and password that will be used. Again, we'll go ahead and say that the username should be one that's injected, and the password was injected as well. We'll go ahead and build this. There are a number of different implementations of token provider for the various different OAuth grant types that you might have, such as client credential grants. But you can also implement your own quite easily, so that you can come in here, and if you wanted to say, for example, look into the Spring security context of a given request and pull out a token from there, you could do that as well with your own custom token provider. So now that we have a Cloud Foundry operations, let's go ahead and give this a run and see if anything happens. When we run the application, gets to the end, and nothing interesting has happened because we haven't made any invocations with the Cloud Foundry operations. So how do we use the Cloud Foundry operations? The Cloud Foundry operations exposes a number of high-level groupings of the various APIs that we might want to use, as well as things inside of them that you might want to do. So in this particular case, because we want to list the applications in our particular space, we'll start with applications, and then we come down here and it takes a list. And we see that the list returns something called a flux. And this flux of application summaries basically means we're going to get a stream of all of the application summaries for all of the applications in our space. The next thing that we need to do is subscribe to this. So we'll go ahead and subscribe to it. And when we subscribe to it, it gives us a couple of methods that we can invoke. And the one that's most important to us today is we want to consume this application summary. So if we had an application here, we could then say system.out.println that application. And this will go through and print this particular application. And I'm going to take the suggestion from my IDE here, and I'm going to simplify this with a method reference. If you're not familiar with Java 8 method references, I highly suggest that you go and do some research and find out exactly how they work. So now we see that we're going to grab our applications, we're going to list them, and we're going to print out the output that returns from it. So let's go ahead and run this again and see how it works. We go ahead and run it, and once again, nothing has happened. And this is because of the thing that's probably most commonly forgotten when people move to reactive programming. And that is, in many reactive APIs, all the operations that you're going to try and invoke are actually asynchronous. So subscribe, that we see here, this line, starts the behavior of listing applications, but it doesn't block, it doesn't hold the process open. So the process will actually finish long before the server has actually responded to us. So the most common way to deal with this is to work inside of a container that doesn't end. So in a web application, for example, threads can take as long as they like, and you can have asynchronous operations that will eventually return, and the application server around it won't actually shut down. However, we're writing a much simpler application here, and this application will shut down, and we need to add some stuff around it to make sure that it doesn't go away. So the way we do this typically is using something called a countdown latch. And a countdown latch allows us to say, I want to wait, or await in this particular case, for a countdown to approach 0. We started this case at 1. And we're aiming to get to the end. Now, where exactly are we going to unlatch this effectively, count down this particular latch? And if we take a look inside of the subscribe, we used a very simple case that only takes a single argument. It says, as each application comes in here, I want to print it out. What we also want to do is use a more complex version of this same thing. And the second argument is, what should I do when an error is thrown somewhere above this? We know that in the case of something like a try, catch, finally block, even in an error case, we want to make sure that we unlatch this so the application can finish. So we'll say, here is our T, our throwable, and maybe we want to say T.print stack trace, so we'll see what exactly went wrong, and then we'll want to count down this particular latch. So that's what happens if this finishes with a failure, but what happens if it finishes with success? And that is the final argument to subscribe. And this is a closure that should run whenever the final value has been passed to subscribe and we've completed absolutely successfully. In this particular case, we'll use one of those method references again, and we'll count down. So to summarize, what exactly we're looking at here is the idea that we want to wait until our countdown latch, which starts at 1, gets down to 0. And we know that if we get to the end successfully, it will count down to 0. And if we get a failure, it will count down to 0. But under no other circumstances will the process be allowed to finish. So if we run this application again, we'll see an application summary come back. And if we take a look at this, this looks like it's probably a Java 2-string method. It doesn't look anywhere near as nice as the output we saw from the CLI. If we take a look back at that one, we see that there's nice tabular data rendering with user-readable values. So what we want to do to get to that is we want to change the formatting here. We want to map it. So the way this works in a reactive programming language is we call a function. There are a great number of things that we can do on this stream of data. If you see, there are a ton of different operations that we can do. But the one that we actually care about is to map something. And in this particular case, when we're given the application summary, what do we want to do? We have a utility back in the background that I've written earlier that allows us to format these. So if we take a look at formatting utils.format application, and we'll pass in that particular application summary. And once again, we'll take the suggestion to replace that lambda with a method reference. So now, each application that comes through our flow, starting with this list, so if we get multiple ones, multiple instances will come through this flow individually, the first thing we'll do is we'll format that particular application into something human readable, and then we'll print it out, and eventually we'll count down and finish. So let's go ahead and run that again. And this time, we see that same application. Java main application has been started. There's one instance running of the one you want to run, 512 megs of memory, 1 gig of disk space, and a URL that this is actually mapped to. So this is how we would replicate CLI behavior. But if you're just replicating CLI behavior, it's not obvious that writing your own programs is the way to go about doing this. Instead, what we might want to do is enhance this behavior. So as we can see right now, nothing is ever said about the services that are bound to this application. If we go back to the terminal and type CF services this time, we can see that there is in fact a service, and that service is bound to the Java main application, but the CLI never shows that same information from the other side. And it is actually quite interesting a lot of the time to know exactly what services are currently bound to an application. So let's go ahead and enhance this by using the Cloud Foundry client to get the information about the service instances that are bound to a particular application. So the first thing we need to do is grab one of those Cloud Foundry clients. Now that we have a Cloud Foundry client, we're going to attempt to get a bunch of service instances from it. So the way that happens is, given an application, we want to basically invoke another asynchronous flow. And the operation for doing this is called FlatMap. And FlatMap basically is different from map in that map happens completely synchronously, has one single input to one single output. In our particular case, we want to do something that is potentially asynchronous and maps from a single input to, again, a single output, but possibly multiple outputs if we wanted to go in a different direction. So once again, we have the application passed in, and we need to do some work with it. So the first thing that we want to do is get a set of service instances. The way we would typically do this is we would say get service instances, and we would pass in a couple of different pieces of information. The first is the Cloud Foundry client that we're going to invoke things against. And the second thing is the application that we want to get the service instances for. And we're going to let this fail for the moment while we go off and create this particular method. Let's come down here to an open space. So we're going to create a new method, and this method returns a list of strings. This is going to return a list of all of the service instances related to this particular application. As we said before, it takes a Cloud Foundry client, and it takes an application summary. And then what does it do with it? Well, the first thing we do in Cloud Foundry land is we want to get a list of all of the service bindings associated with a particular application. So we'll go ahead and request service bindings. Once again, passing in our Cloud Foundry client. And the application summary. So what does it mean to request a set of service bindings? In this particular case, it's going to return a stream of those service bindings. And it will do that by saying Cloud Foundry client dot service bindings. In this particular case, there are two different kinds of service bindings. And we want to list those. So we list those by passing in a list service bindings request that takes a set of filters. And the first filter we're going to do, in fact, the only filter for this particular one, is we want to pass in the ID of the application we're trying to get service bindings for. So we'll go to the application summary. We'll find out the ID of that particular application. And that will be the request that we use. It would appear that I've grabbed the wrong, okay, so this returns a payload that is a single mono that contains a collection of other things inside of it. So once again, we'll take that mono and we'll map it so that we have a response, and we'll say response.get resources. And we'll make that iterable. This now transforms what was a mono, and we pulled a collection out of it and created a flux out of the contents of that particular collection. So again, we'll simplify this for readability. So our service bindings now have a list, our get service instances has now gotten a collection of service bindings, a stream of service bindings. But service bindings don't actually have, for example, the name of the service. It has two different IDs, one end for the service instance and one end for the application. So if we were to take a look at that, we couldn't tell what the name of the service instance is. So once again, we need to actually map this. The first thing we'll do is we'll extract the service instance ID. And then we'll go look up with that service instance ID the details about the service instance. So what will that look like? Well, once again, take a look at our Cloud Foundry client. We'll take a look at service instances, and we'll get a particular service instance. We know that the service instance ID is the one we passed in, and we'll return that from this particular method. So we've gotten here to now having one of these service instance responses, but that isn't this list of those names. So the first thing we do is when given a service instance, we're going to map that. To its name. And then we want to collect all of these possible service instances into a list. And that is what we're going to return instead. So we've broken this down into a number of different methods, but fundamentally what we're doing is we're requesting a set of service bindings. We're extracting the ID of each one of those service bindings. We're then going to look up the service instance data related to that service instance ID. Then we're getting the name out of that service instance ID, and then we are collecting it into a list. So now if we go all the way back to the top of our application, we now have our get service instances here, which we want to pass through. The problem we have is we still need all of the information we had before. We still need the application metadata so that we can print that out before we get to the point that we print out exactly what the service instances related to it were. To do that, we need to carry along context. And in this particular case, the way we do that is we simply create an empty mono that contains the original application, and then we say, and the contents of this thing right here. So now what we get is something called a tuple at the other end. Now we get something that looks like a single object containing both the application data and the list of service instances. We'll use a utility called function that allows us to automatically extract those things out. And so we'll say application and service instances. And this time we'll once again do a formatting utils dot format application, and service instances. Go ahead and import that method. And so now we see instead of passing along just the application, we pass along both of those pieces of information. Once again, we'll simplify it for readability. Go ahead and simplify this guy for readability as well. So now when we run the application, we should see it extract all of the same data we saw before. And in this particular case, it will print more data than the CLI does, the bindings for the service instances themselves. We see it's listed the service bound to my particular application, in addition to all of the stuff we saw before. So to go back and summarize again what exactly we see here, we use the Cloud Foundry operations to do a high-level listing of all of the applications inside of my space. Once we have that application, we want to preserve the context for later on, but we also want to go get a list of all of the service instances attached to this particular application. Once we have that information, we pass both the application and the services instances attached to it to a formatter, which then prints out via the subscribe method. If there was ever going to be a failure, we would print the stack trace and then count down the latch. And if it completes successfully, we will also count down the latch. Finally, we await the counting down of that latch at the end to guarantee that our application does not finish early. So that concludes the coding part of this presentation. Let's go ahead and answer some of the questions that have come in.
Great. Hey, Ben, thank you very much. That was fantastic. And Paul, thank you both. Paul, I was noticing, Ben kind of coding through this example using a Spring Boot annotation. And one of the questions we've heard frequently from people as they encounter this new sort of 2.0 version on this sort of major, kind of reactive overhaul of the Java client is, does it really require Spring Boot? Can you talk a little bit about that?
It's a good question, Peter. Naturally, we're quite fans of Spring Boot, so we tend to use it when we're putting together little demonstrations like this. But we've been very careful not to get Spring stuff involved in the CF Java client. So the only requirement we have really is that you have a JVM. We've not actually tested it against things like Kotlin, but there's every chance it would work. Certainly it works fine in Java 8.
Fantastic. Okay, so you could pretty much use it for anything. That's just, the only real requirement is Java 8. Got it. Okay, so that's great. One other common question we've heard is that, this is a client API, so you need a server if you want to, play with this thing, right?
So there are two easy ways to get a hold of Cloud Foundry to test the Java client against, and just basically to understand how Cloud Foundry works in general. And the first is to use our public cloud called Pivotal Web Services. And Pivotal Web Services has a free trial. You just log in, you get an account, and walks you through the how-to to push your first application to Cloud Foundry. And once you have that up there, it gives you all of the credentials that you need to actually use the Cloud Foundry Java client as well and experiment with that. If you're in a situation where using the public cloud, even for experimentation, doesn't work for you, you can also register with pivotal.net and download a copy of something called PCF Dev. And PCF Dev is a small, lightweight version of Pivotal Cloud Foundry that runs in a single VM on your local machine. And the CF Java client works with this as well because it is a full-fledged version of Cloud Foundry, complete with all of the APIs that you'd expect, both Cloud Foundry APIs and UAA for user administration and authorization and those kinds of things. You should be able to test the Java client against that as well.
Awesome, great, thank you, Ben. Question from from Bertie. And he says, what's a good use case for the Java client?
So there are a ton of really good use cases for the Java client, but anytime you're trying to write an application that orchestrates behavior on Cloud Foundry. So for example, if you wanted to write an automated system that knew how to deploy applications or to figure out what applications were currently running, or we see even inside of the Spring community, there are a number of projects that build on top of this client as well. So for example, we have the Spring Cloud Data Flow project, which needs to deploy and undeploy and configure and scale and all of the typical Cloud Foundry things, a bunch of different internal components for data processing. So they actually build on top of the Java client to automate the pushing of applications and the scaling of applications and deletion of applications when they're done. And the same thing is true for end user applications. Anything that needs to deal with Cloud Foundry itself is well served by the Java client.
Excellent, thank you. Okay, great, Bertie, so thanks for that question. And then, Ben, another question I hear frequently is just, how much of the Cloud Foundry API is actually supported?
Yeah, so for this very first release, version 2.0, so for this first modern release, version 2.0, we attempted to hit as much of the API, both the Cloud Foundry Cloud Controller API, the UAA API for authorization and authentication of users, as well as the Doppler API for dealing with logging and metrics, as we possibly could. It is incomplete today, but if I had to sort of put a number on it, I'd say we've covered about 2/3 of the APIs that are available to us. There are about 550 different endpoints that we could implement.
But again, we hit the stuff that most people are going to need on a daily basis for this first release. So let's call that an MVP, a minimum viable product. And we have a long-term plan to implement absolutely every single one of those APIs that makes sense sort of in an automated development environment. And then we have a long-term commitment to making sure that it keeps up to date for various changes to Cloud Foundry as it evolves.
Cool.
It's worth noting with that, Peter.
Yes,
it's worth noting with that we run our integration test against PCF Dev before we push it out to our version of production. We tend to run the integration test locally on PCF Dev. It's a really good environment as long as you've got a reasonable laptop, well worth using.
Yeah, I seem to recall, I think they recommend like 16 gig of RAM. I mean, you can kind of get away with 8, but, if you're running a lot of unit tests, you probably want 16. And yeah, no, we've heard some good feedback on that, so absolutely, that's cool. I didn't realize that. Thank you, Paul. One of the other common questions that we've heard from folks are, just how is this used? Can you give us a sense of, Paul, can you give us a sense of some common use cases? Like, why do people want to connect why do developers want to connect to Cloud Foundry programmatically? What are some of the things they typically are doing or wanting to do?
Okay. Basically, it's there if you want to do anything to do with orchestrating applications that you're running in Cloud Foundry. So a very simple use case for it would be if you were running CI and you wanted to be able to deploy an app onto Cloud Foundry so that you could do some testing against it or maybe even put it into production. So that's a fairly limited usage. It can go right up to major production systems. A good example that we have internally is Spring Cloud Dataflow, which is a relatively new system for managing big data stuff, so stream processing, batch processing, things like that. And what they're doing is they are deploying microservices to handle streams. They are chucking out new ones. They are scaling up, scaling down, killing old versions, etc. So they rely on our library to be able to do all of that so that they can worry about doing the things that they're actually interested in doing. So it can go really from the very, very simple cases right up to full production.
Fantastic. All right, got it. That makes sense. Got it. So really kind of orchestration needs if you're looking to automate things, especially CI. Okay, that's interesting. All right, thank you for that. And then maybe if you could give our listeners, Paul, a sense of, obviously the Cloud Foundry's, I think it's the Cloud Controller API, effectively, that it's pairing against. Did I get that right?
That's one part of it. We actually go against 3 different APIs that are part of the Cloud Foundry family, as it were. So there's the Cloud Controller, which is the CF API. That's the main thing people will think about. But we've also implemented UAA and Doppler, which is the logging side of things as well.
So of the total sort of surface area of what's available in the Cloud Foundry API, I mean, how much would you say has sort of been addressed by the Java client in this kind of reactive rewrite and sort of, relaunch of the client as 2.0?
So at the moment, we reckon there are about 500 and something endpoints that we're looking at. We've got about 2/3 of them already, and we think we've hit all of the sort of the big ones. We're starting to get into some detailed level at the moment. So as it is, 2.0 is a perfectly usable product for almost any application. But we have committed to implementing all of the endpoints across the CF, UAA, and Doppler. And as well as doing that as a one-time effort, we're also then committing to keep it maintained. So CF is changing quite quickly. They're still doing a lot of work on it. So we're going to try and keep up with that and make sure that we stay 100% coverage.
And Ben, I remember you once telling me that there was a fair amount of community and external participation in this project in particular. Is that the best way for people to get involved? Is that the GitHub repo? Anything else you'd want to say to maybe folks that might be really interested in this and might ultimately be looking to contribute or get involved in some other way?
I think just the two most important things to take a look at are obviously the project's website on GitHub, or the project on GitHub. And that project will allow you to create issues, pull requests. You can see on the README that's in there different configuration that you might want to make, and some examples on how to actually use it. And then obviously the slide, or the repository that contains all of the slides for this particular presentation, and all the source code as well.
Okay, great. Hope you folks come back next month. Paul, it was really great having you on, and Ben, thank you. And look forward to having you back to talk about other Cloud Foundry and Java topics on the program. Really appreciate your time. And yeah, if there's anything you want to say before we call it a wrap, please go ahead.
I would just add, go to GitHub, take a look at the code. Even if it's not something you're going to be using directly, I'm proud to say that Stefan Maldini, who is the lead on the Reactor project, holds up our code as an example of what a properly done reactive code base will look like. So it's well worth taking a dig in there. Have a look at the tests that we've got, particularly the integration tests. They're a very useful example both of how CF Java client works and also a way of using a reactive API in general. So get dug into the GitHub. Let us know what you think. Thanks very much, folks.
Have a good day, everyone.
Thanks, everyone. Hope to see you at a webinar again soon. Have a great day. Take care.